Okay, here's a quick video to go over what we went in class on January 22nd, Wednesday. So we were working on making the connection of an equation to a graph for quadratics. For our warm-up, we talked about the quadratic web that I had you guys do yesterday on your homework, and I asked you to make connections between things like situations and graphs and tables and graphs, and draw all the connection lines that you do know currently how to do. So if you didn't get a chance to do that in class today, you can come back and talk to me tomorrow and we can take a look at that. So your goal for today was to be able to sketch a graph, give an equation without the use of a table. So if I give you an equation, and the equations for these quadratics typically look like something like this. So if we have like x squared plus 2x plus 1, y equals that. That's the equation that I'm talking about, that you should be able to sketch the graph that it goes with it. So if you look at what we did yesterday, one of the situations that I gave you was for Maggie's graph, I think. And I told you that her water balloon she started at the 3-yard line, and her water balloon ended up going something like this. And I told you that the equation of her water balloon was y equals negative x squared plus 17x minus 42. And yesterday you had to put this into a table. Most likely you plugged in points for x's and got out points for y, and then were able to plot it on your graph. So what today we're working on is, can we go straight from this graph to the equation? Are there certain things in here that can help us do that? And think about when we did linear functions, when we had things like y equals 3x plus 2. If you remember what this told us about the graph and what this told us about the graph, okay, we're kind of looking at the same thing. How can I get some certain things out of this that will apply to the graph? So the first thing you want to do is write down in your notebook is write equation to graph. That's going to be the section that we're going over today. And the first thing you want to write down is this question here. What do you need to sketch a parabola? I want you to pause the video and take a couple minutes and write down all the things you think you need to sketch a parabola. To give you some direction here, I know that you need points to put a graph on a grid system, but don't just say points. Be a little bit specific. What points do you need? So if you look at yesterday's activity, what points did you have to have in yesterday's activity to be able to make all those grids? So take a second and pause the video and write those down. Okay, so if we think about what we needed in the video, some answers that people gave in class, and I'm just giving you all these answers. We may not need them all. We may need only some of them. We may need more than this, but these are just the ideas that people came up with in class. So some people said that we absolutely have to have the vertex of the graph, which is the point where it's either the highest or the lowest at. Some people said that we had to have x-intercepts. And some people said we needed y-intercepts. And some people said that we needed, I think that was it. Oh, and the direction the graph goes. Okay, so these were some ideas from other students. You may need them all, you may not need them all. Hopefully you recognize some of these from your own. So the lesson we're going to do right now will kind of explore this. So if we look here, what I want you to try first is, can you sketch a parabola if you only know what the y-intercept is? So on your notes, I want you to write y-intercept, put a question mark, and then go ahead and get out graph paper or just kind of sketch it on your own. Is this enough information to draw a parabola? So given this y-intercept at 0, negative 15, can you sketch the graph of that parabola? Go ahead and pause the video and try this. Make sure that you have a reason why or why not. Okay, now that you're done sketching that, well, what we found out in class today was that if we put our y-intercept here at 0, negative 15, that's not going to be enough information, because we don't really know if our graph goes up or it might go down. Okay, that might be the vertex. We don't really know. We can't really tell where things are because we don't know anything besides the y-intercept. So we need to know what direction it goes. We need some x-intercepts maybe. We need to know where our vertex is, maybe the direction, but this is not enough by itself. Okay, the next question we want to look at is what about the two x-intercepts of the parabola? If you only know where the x-intercepts are, can you draw the parabola? For example, if the x-intercepts are at -3, 0 and 5, 0, can you predict the path of the parabola? So go ahead and pause this video and take a second and graph -3, 0 and 5, 0 and see if you can make a parabola from that. Okay, when we did this in class, this is what we figured out. Everybody made a little sketch, and we had our points at -3, 0 and 5, 0 right here. And again, we decided this is not enough information because I don't know, does the parabola go like this? Does the parabola go like this? I can't figure that out. There is one thing that I should be able to figure out. What does knowing those 2 points tell me about my graph? Well, somebody said that it will give me the line that goes down the middle of it. So if you think about this, if this is -3, 0 and this is 5, 0, where is this line going to go through? So -3 and 5, well, if I think about that, what's halfway between -3 and 5 on a number line is going to be 1. So this line will be through 1, 0, and every point on this line will have an x-coordinate of 1. So this is going to be the line x equals 1. Okay, so I know where my line of symmetry is. How does the line of symmetry relate to the vertex of the graph? Take a second and think about that. How does this line of symmetry relate to the vertex of my parabola? Well, what you should say is that the vertex sits on that line of symmetry. So I know a little bit about my shape. It might go down a little bit more. I know that the vertex has to sit on that line, but I just don't know exactly what it looks like. So my next question was, can you sketch a parabola with only its x-intercepts and y-intercepts? To test this idea, sketch the graph of a parabola with the equation y equals x squared minus 2x minus 15 with roots, and we'll talk about what roots are in a little bit, but they're my x-intercepts, of -3, 0, 5, 0, and a y-intercept of -15. Where is the line of symmetry? So take a second, pause the video, and graph that. Okay. When you come back here, we're going to have our -3, 0, our 5, 0, and I gave you your y-intercept. Is that y-intercept the vertex, and how do you know? Well, no, it's not going to be the vertex because this is not going to be a mirror image. If I sketch this, the graphs have to be a mirror image, and this side is not going to be a mirror image of this, so that won't work. Okay, again, I know my line of symmetry is still the same thing at x equals 1, but right now, with this information, am I able to figure out what this graph looks like? Well, the problem is I still don't know where my vertex is going to go. I know the direction it has to go now, because I know this, okay, so it's going to have to go up, but the problem is I still don't know where that vertex is. So the only other thing you want to think about is I gave you this equation, y equals x squared minus 2x minus 15. If I know that equation, is there any way that I can find out this vertex? So if you think about it, the vertex, what do we know about where it needs to sit? Well, we know it needs to sit on this line of symmetry. So what does that mean one of its coordinates are going to be? We know the x is going to equal 1. Is there any way that we can find the y knowing the x equals 1? We can use our equation. So 1 squared minus 2 times 1 minus 15 is going to give me -16. So I now know my vertex is right here. And now I can kind of connect this and figure out that it's going to go like this. Okay, so for this part in your notes, go ahead and label this x-intercepts, y-intercept, and equation. So that's if I have all this information. Okay, in the previous one, so x-intercept, y-intercept, and equation. In the previous example, I forgot to put this. We just had x-intercepts. And we said, no, not enough. And we said, yes, this was enough. Now here's my question. Do I need this y-intercept to be able to sketch the graph? And if we think about it, I actually don't need this point. Once I have my vertex and my 2 points here, that's enough to figure out what the mirror image is. So really, all I need are my x-intercepts and my equation. Okay, the only other thing is, can I get my x-intercepts from my equation? And we're going to talk about that in a little bit. That's kind of our goal today. The other kind of thing is, what if I have a graph like this? What do you notice about that one? How's that different than this one? If you notice, there's no x-intercept. So this time, what would I have to know? I'd probably have to know a vertex, and if I knew my y-intercept, and I knew my vertex, I'd know my line of symmetry, so I could reflect that over and get this point here. Okay, so we're going to kind of look at some of those examples too. So the next thing we want to think about is, in problem 864, which is the previous problem, you learned that if you can find the intercepts of a parabola from a rule, then you can sketch the graph without the table. So what is true about all the values of y for all x-intercepts? So when we have points that intercept with the x-axis, what's true about the y values? Well, they're going to be 0 at that point. What's true about the values of x for all y-intercepts? So when we're intercepting the y-axis, what's true about x? Well, that's 0. So go ahead and write this exact thing down and calculate this. If x equals 0 at the y-intercept, find the y-intercept of this equation. Go ahead and write this all down and pause it. Calculate the y-intercept. Okay, you should have this written down here. You should be able to say y equals 2 times 0 squared plus 5 times 0 minus 12. And you're going to get y equals negative 12. So at the point 0, negative 12, I have my y-intercept. Okay. Next thing here, since the x-intercepts occur when y equals 0, write the equation you would need to solve to find the x-intercepts for the graph of y equals 2x squared plus 5x minus 12. Go ahead and pause the video for a second on that. And when we come back, this time we wanted y to equal 0, so y was right here in that spot. So I'm going to say 0 equals 2x squared plus 5x minus 12. So if I could solve this and find the x's here, I'd know where my my x-intercepts are. So let's think about that for a second. Please write this down. The roots or zeros of a quadratic expression are the values of x that make the value of the quadratic equal to 0. So if we think about that for a second, what are we really saying? If we look back here, I said the roots are the values of x that make the value of the quadratic equal to 0. So basically I'm saying, what x can I put in here that will make this equal 0? Those are called roots. And go ahead and write an x-intercept of a quadratic is a root. So at this point, can you solve for x? Well, not quite yet, but we're getting there. Okay, you don't have to write this down, but just think about this for a second. The zero product property. The equation you wrote in part C of problem 8-65, which is what you just did, it's called a quadratic equation. To solve it, you need to examine what you know about 0. Study the special properties of 0 below. So, Nathan, Sonia, and Gaston are playing a game where Nathan and Sonia each think of a number and then give Gaston a clue about their numbers. Using the clue, Gaston must tell them everything they know about their numbers. Nathan and Sonia's first clue for Gaston is that when you multiply their numbers together, the result is 0. What conclusion can Gaston make? Well, we should know that one of the numbers has to be 0. Both of them could be 0 also, but at least one of them has to be 0. Disappointed that Gaston came so close to figuring out their numbers, Nathan and Nancy invited Nadia over to make things harder. Nathan, Nancy, and Nadia all think of secret numbers. This time Gaston is told that when their 3 secret numbers are multiplied together, their answer is 0. What can Gaston conclude this time? Well, again, at least one of the 3 numbers has to be 0. More of them could be, but at least one of the 3. So does it matter how many numbers are multiplied? If the product is 0, what do you know about one of the numbers? Well, it has to be 0. This property is called the zero product property. So what I want you to do is to write a description of this property in your journal. Title this entry Zero Product Property and include today's date. So just put that under today's lesson. This is as far as we got in class today, so if you can get all caught up with this part, you will be good to go tomorrow. Have a great day. Bye.